So yesterday my DSLR camera's battery got exhausted and that's why I had to start once again from here. So I'll start where I had left yesterday. If you remember, we had studied that this is f of n, this is c and this is g of n, and over here we had studied that k1 is less than k2 is less than k3. This mathematical property means that as the value of n keeps on increasing, f of n becomes smaller and smaller than some multiple of g of n. Now this mathematical property is called asymptotic notation, the heading which you gave. So now I can say that f of n is asymptotically bounded by g of n, or I may say that f of n is bounded by g of n from above. Now what exactly that word above means? It means that no matter what happens, f of n will never be greater than 2 into g of n. It will be either less than or at the most equal to 2 into g of n. So this is called asymptotic notation. This property which you see is named asymptotic notation. Now once you understand what is the big O notation, let's try to understand the advantages of the big O notation. So big O notation has two advantages. Let's talk about the first one. Let's say there is an algorithm whose f of n is this. F of n is equal to 8.674 n square plus 7.58 for n raised to 4 by 3 and so on. It starts from here and it comes till here. By the way, in the real world, the f of n of algorithms is a complicated expression like this. Let me come out of the screen so that you can see that properly. So that's the whole expression. Now let me ask you a question. If this is f of n, what will be g of n for this particular f of n? Take a moment. For this particular f of n, g of n will be n squared. So now I can write that for this algorithm, f of n is big O of n squared. A simple question. What is easier to say? Is it easier to express the efficiency of the algorithm in terms of f of n, or is it easier to express the efficiency of the algorithm in terms of g of n? The answer is obvious. This is far easier than this thing. So the first advantage of big O notation is simplification. See, what happens is when we express the efficiency in terms of g of n, we are simplifying the entire process of expressing that efficiency. Alright. In exam, sometimes you may have a question, what is big O analysis? Very simple. Given f of n, you find g of n, that is called big O analysis. Once again, you are given f of n. From that f of n, you find g of n, and this is called big O analysis. So that gives you the first advantage of big O notation. I repeat, the first advantage of big O notation is simplification. Now let's talk about the second advantage of big O notation, very important. And in order to understand the second advantage, let's go back to that example which we have seen. If you remember, you saw something like this, n square plus 100n less than equal to 2n square. This was f of n, this is c, this is g of n. I hope you remember that. Also remember one thing, I have told you that in this particular subject, whenever you see something in terms of n, that thing is time, execution time. So this n square plus 100n is the actual time taken by the algorithm. I repeat, it is the actual time taken by the algorithm. If that is the actual time taken by the algorithm, can you think and tell me what is this time? Take a moment. 2n square over here is the maximum time taken by the algorithm. Yes, that's right, maximum time. So, when we write this expression has a very deep meaning. What it means is that no matter what happens, the time taken by this algorithm will be either lesser than or equal to 2n square, but the actual time will never exceed 2n square. So, the big O notation of any algorithm gives us the maximum time taken by that algorithm, and that is the second advantage of the big O notation. You may ask me, why is the maximum time of the algorithm so important? So the answer is very simple. Whenever any new software is developed, it is designed not considering the actual time that software will take. It is developed considering the maximum time that software will take. So recollect the example of missile defense software. If at all the missile defense software is developed, the developers will think this way. They will design the software in this manner, that our missile should destroy the enemy missile in let's say maximum 23 seconds. No matter what happens, the enemy missile should be destroyed in 23 seconds. Now, if the enemy missile gets destroyed before 23 seconds, before it falls on us, it is a good sign. So please understand one thing, that whenever a software is designed, it is designed considering the maximum time and not the actual time. And this maximum time is given by the big O notation. So that was the answer of big O notation. What I would suggest is that please copy this answer point-wise from some of your friend who has already attended the lecture in the class. Now, after big O notation is over, there is one more thing I want to talk about, and that is this n. We always say that n is very large. We always say that n is very large. Now, in your Viva, in your oral exam, the examiner may ask you why n is considered to be very large. So the answer is something like this. See, what happens is, whenever a software in the real world works, it always works on a very large value of n, and that is why we also take n to be very large. Now, to explain that to you, let me give you an example of ATM machine. Let's say you go to the ATM machine, you insert your card. What the ATM machine will do is, it will read your account number, your customer ID from the magnetic strip of the card. Then the ATM machine will ask you for your PIN. Now what the ATM machine should do? It should check whether your PIN is valid or not. Now think like a computer engineer, how the ATM machine will come to know whether your PIN is valid or not. So what the ATM machine will do is, the ATM machine will search your account details in its database. In other words, your account number will be searched, will be compared with all the other accounts which are in the database of that ATM machine of that bank. Now, if you take example of a popular bank like SBI, this bank will definitely have 10 lakh customers, 10 raised to 6, 10 raised to 7 customers. So that means what the ATM machine is doing, the ATM machine is comparing your details with the details of 10 raised to 7 customers. In other words, the program of the ATM machine is working on 10 raised to 7 elements, and this 10 raised to 7 elements is nothing but n, which is very large. So the real world programs work on a large value of n, and that is why we also consider n to be very large. So that was the big O notation and why n is very large. Now for the remaining topics, we will move on to a PowerPoint presentation.